All right, last section, you guys. And it's a big section at that, so I apologize. But in this section, we're going to talk about a bunch of stuff. We're going to start off with histograms. So with histograms, you're going to have a data set. Wish I wouldn't have made it so big. But you're going to have a data set. You're going to have to put it into a frequency table. I gave you this, and as far as your intervals that you had to fit it in, and then we're going to go ahead and create a histogram over here. So first off, let's look at our frequencies. So we look for numbers between 11 through 15. There's 1, 2, 3, 4, 5, 6, 7, 8. 16 through 20. There's 1, 2, 3. 21 through 25. Look, there's none. 26 through 30. So that includes this 30. There's 1, 2, 3. Oh, excuse me. 4. 31 through 35. There's 1, 2, and 36 through 40. 1, 2, 3, 4, 5, 6. All right, so we've created our frequency table. We now need to make our histograms based off of that. A couple things you need to remember about your histograms. Your frequencies. I'm just going to put FREQ goes on that side. Your numbers goes on bottom. Make sure that you're labeling your sides. We need to get it to where it's pretty even. So there's 1, 2, 3, 4, 5, 6, 7, and 8. I'm going to go ahead and label those 1, 2, 3, 4, 5, 6, 7, and 8. And then we have these intervals. So there was a couple different ways that we could do these intervals. One of the easiest ways was to just go ahead and put the interval underneath the histogram column. So that's what I'm going to do. But in this case, since we don't start at 11, we cannot start our histograms on the y-axis. Remember, there was that little heartbeat looking thing, and then we can start our histogram. So that first one goes all the way up to 8 and over. The next one only goes up to 3. And don't forget, histograms have to be connected, and we need to try to keep those columns the same width. The next one we have 21 through 25, there's a blank. So I'm going to try to make a blank about the same width. We call that a gap. We then go up to 4 and over. Still keeping in mind, trying to make it the same width. It might be a little bit off. The next one, 2. And then the next one is 6. So we're going up. All right, and then so in this case, what I'm going to do for my intervals is I'm just going to use those 11 through 15, 16 through 20, 21 through 25, 26 through 30, 31 through 35, and 36 through 40. Remember, besides that, we had to label them with our starting points. So we could have used 11, 16, 21, 26, 31, 36, and then this would have been labeled 41, not 40. Even though it's our ending point, histograms, it demonstrates it as a starting point. All right, so what if we're looking at histograms and there's errors? There were some things that we had to remember. So first off, if I look at these, we can look at our labels. That's good. This one's missing labels, so I'm going to write that over here. All right, if I look at this, see how this is obviously not a 0. Well, shouldn't start at 0. Or shouldn't start on y-axis. So there's a mistake. For the most part, these are all touching. I can't really tell and see if those intervals are all the same, which it looks like they are: 195, 200, 205, 210. So those all look good. The widths all look right. But if I look at here, these are not connected. This is more of a bar graph than a histogram. They need to be connected. So we need to have that as an error also. Gaps unneeded. I don't know if this is actually a word, but we're going to write it. The gaps are unneeded. Now we can have gaps like we did in the other one. We can have a gap like this right here. Except that gap has to be surrounded by data and it has to be representative of a 0 frequency. That's not what these gaps are. Notice you go 0 to 10, 11 to 20. Those gaps are not the same. Another thing that you could say is that since this does start with 0, this should be on the y-axis. Should start on the y-axis. So there's a couple things that we saw. Some other things that we could have as a mistake. Things are not the same width. You might have intervals that aren't the same. So those are all things that you need to be looking out for. All right, give a definition or draw a picture. Skewed left. I'm going to draw a picture real quick. So remember, we talked about skewed left as the tail is to the left. So if we had something like this, excuse me, let's not draw it as that. Let's draw it as a histogram. And it doesn't have to be perfect, but if your tail, right, this is my mouse, most of my data, there's my tail, that's skewed left. The opposite would be skewed right. So most of your data and then you have a tail. So data and tail, that's skewed right. Symmetric is going to be just about even on both sides. Remember, we talked about this is like horseshoes and hand grenades, right? It needs to be about the same. It's not going to have to be perfect, but about the same makes it symmetric. Unimodal, remember we were dealing with how many modes that you had. We talked about how many humps that you have. So unimodal would be something just like this. So I'm just going to draw you an arrow so we don't have to waste time. Bimodal is going to have 2 humps. So you go up, back down, back up. That's bimodal. And then multimodal is just going to have more than that. So could have 3, could have 4, anything more than that. Keep in mind that we didn't really talk about uniformity, but you could have something that's uniform. Uniform would just be something that pretty much looks like this. You could have a little bit of discrepancy, but it's pretty much looking like that. And then outliers, this one thing. When we have outliers, you're going to have most of your data, a big chunk of it. You know, we're all sitting right here. It doesn't really have to follow any other type of pattern. You know, and then all of a sudden you have a huge gap, and then you got a little bit of data out here. So we just talked about outliers in general terms, saying that it's way, way far away from the data, but that would be considered an outlier. Write out the steps that you would take to find the center of a histogram. In order to find the center of a histogram, we're going to have to find frequencies of each column. Add them together. Excuse my language right here. Add them together. You like that? After we add them together, we're going to divide by 2. That's our middle digit. Find that digit or value. Matter of fact, let's not use the word digit. Find that value. And you're going to see us actually put that to practice here in a second. So it says, Mr. Winger recorded the grades of his students' final exam with the histogram below. Identify these characteristics. So shape dealt with that skewness, right? And so if we look at it, it looks like I have a chunk of data and a tail. So in that case, the tail's to the left. I'm going to say skewed left. The modality looks like there's only one hump to me. So in that case, it's going to be unimodal. The center we'll look at here in a minute. Remember, your range is from start to finish, so 0 to 100. It's a histogram, so I'm not going to subtract. I'm going to leave it as that range. Your outliers, no. Our data is pretty much all together, so I would say no on outliers, and there's no gaps. A lot of people got this wrong. They wanted to say, like, if there was nothing right here at the beginning, oh, that's a gap. It's at the beginning. In order to be a gap, you have to have data on both sides. So in this case, no, we don't have any gaps. That's working fantastic. All right, so then our center, we're going to follow those steps that we just did. We already have these labeled 4, 9, 20, 40, and 23. If I add those together, 4 and 9 is 13, 20 is 33, 40 is 73, 23 is going to be 96. So we end up with 96. We're going to divide that by 2. We get 48. So we have to find our 48th data point where that falls. So this is not it because that's only 4. That'd be up to the 13th data point, so that's not it. This would be up to the 33rd data point. That's not it. This would be up to the 73rd data point. So somewhere in this column, somewhere right here in this green column is going to be our 48th data point. Since that's our middle data point, we're going to use these as our center, a range of 60 to 80. The big issue is with the histogram, we don't know exactness, and so we have to use that range to be able to identify a center. How many students are in Mr. Winger's class total? We just figured that out. We added all these together, our frequencies, and we ended up getting 96. How many students got an A or a B on the final? So an A or a B is anything above an 80. So that would be my starting point. So anything above that, there's 23 kids. And based on the results, do you think the test was too hard? It's kind of one of those questions you just have to answer yourself. If you look at it, your middle grade was somewhere in between a 60 and an 80. So 50% of the people, did lower than that. 50% of the people did higher than that. So I'd probably say it's okay. You had 23 people that got a B or an A. So I think it'd be kind of difficult to answer that part right now. Let's go to scatter plots. So in this, there's a bunch of stuff about scatter plots. You got positive correlation, negative correlation, or no correlation. Your line of best fit is the one line that best represents all the data. Correlation coefficient was that number between -1 and +1 that represented the strength of your data. And then if it has no correlation, your correlation coefficient is going to be 0. So then it says draw a line of best fit. Note the type of correlation, positive, negative, or no correlation, and give a plausible correlation coefficient. So in this case, we kind of talked about these like that little depth finder with when you're finding fish. If you can tell the flow of the fish, like this one, well, there's a pretty decent line of best fit. This one, there's a pretty decent line of best fit. This one, there's a pretty decent line of best fit. This one, I can't really tell. So this, I'm going to say A, no correlation, because I can't draw a line of best fit. And my correlation coefficient should be 0. If we look at B, we have a positive correlation. I can tell that it's obviously going up, so positive. In this case, remember our correlation coefficient determines the strength, how close these dots are to that line. I drew the line kind of jacked up, but I'm going to give that maybe like an 80, 75. So since it's positive 0.75. C is a negative correlation. This is pretty similar to B over here, so I would still say it's a negative correlation. And I would still be, around a 0.75, I would think, since it's a negative correlation, or correlation coefficient is negative 0.75. And then this last one, this was an interesting thing. I talked to another stat teacher. Really, it's neither positive nor negative. I think you might be able to make an argument, but at least we can draw a line of best fit in that case. But otherwise, I'm going to leave that correlation alone. All right, looking at the next one, draw a line of best fit with the scatter plot and use it to answer the questions. So this was a mistake that a lot of you guys made on your test. I told you to use a line of best fit, or to draw a line of best fit and then to use it. And a lot of you guys drew the line of best fit and you'd be like, oh yeah, we're good right here. And your line of best fit was fairly accurate, but then you never used it to be able to answer the questions. You used the dots. And so understand, if it says draw a line of best fit with the scatter plot given and use it to answer the questions, we're not using the dots anymore. We're using the line. It said, if you practice 4 hours a week, how many debates should you win? So we're using the line of best fit. 4 hours a week, I go up to my line, and I go over, I should win about 16. So that's how I'm going to write it. How many hours a week would you have to practice in order to win 18 debates? If I wanted to win 18 debates, that's in between 16 and 20, I could go over and go down. So somewhere more than 4 hours, or about 4 hours. What is the correlation coefficient that would accurately represent this data? It's pretty close, right? So it's positive correlation. Those dots are pretty close to the line, so I'm going to give it a little better than what we did over there and call it a positive 0.80. And how does the amount of practice affect the amount of debates? One, more practice equals more debates won, or more winning. Let's just make it easy on myself. So since it's a positive correlation, as one goes up, the other one goes up. That's what that means. If it was negative correlation, as one goes up, the other one goes down. So this case, it was positive. It's going to be a more equals more. All right, number 8. Mr. Branson's trying to lose weight so he can better fit his medium shirts. Right now he weighs 185 pounds. He's going to lose 3 pounds per week until he fits comfortably in his shirt. The suggested comfortable weight for a medium is 135 pounds. Does it represent an arithmetic sequence or geometric sequence, and how do you know? So he's losing 3 pounds per week. So that's a constant difference. So it's arithmetic. I know because it's constant difference of 3 pounds per week. So explicit and recursive formulas. Remember, the two things that you need for an explicit and recursive formula are your first term, which our first term says week 1, he's 185 pounds. And then your difference. We're going down 3, so our difference is negative 3. Your explicit formula, we're going to have a sub n is going to be equal to a sub 1 plus our difference times n minus 1. And then with your, your recursive formula, you list out your first term. And then all you're going to have is a sub n minus 1. So your previous term plus your common difference. So I'm going to use these and just erase what I need. So right here, I know my first term. My first term is 185. I know my difference. My difference was negative 3. I'm going to come back to that in just a second. Over here, I know my difference. It was negative 3. And I know my first term was 185. This I can leave alone. Some of you, that freaks out a little bit with that plus and negative, so I'm actually going to write it as just a sub n minus 1 minus 3. Remember, we talked about your math speak. You don't say Mer Branson, you say Mr. Branson. So if I read this, my first term is 185. The term I'm looking for is going to be equal to the previous term minus 3. So that's how you read that. This one over here, I told you I'd be okay if you left it like this because technically it's a recursive formula, but just in case they go ahead and distribute. When you distribute, you get 185 minus 3n plus 3, which would give you 188 minus 3n. Addition is commutative, so I could move these, and we could end up with a sub n equals negative 3n plus 188. Don't freak out about some of these. If you have it like this, just remember that that negative is going with the 3. It's not by itself. How much weight would he have lost by the 10th week? So the best part about an explicit formula is we can use that explicit formula, plug in a 10 right there. So if we're looking for a sub 10, we can, not plug in, but substitute a 10. Go ahead and multiply. And then our 10th term should be 158. Now, something that we said that you don't need to freak out about, if you completely forget about doing this, well, list them out. He's got 185, and I'm not going to list all of them. but 185, he lost 3 pounds. He's at 182. He lost 3 pounds. He's at 179. We can keep on going with that. The next one says the local petting zoo is worried that the rabbit population is getting too big to house. The first year they were in business, the petting zoo had 4 rabbits. The rabbit population multiplies times 3 every year. So is this arithmetic or geometric? It doesn't ask that question, but it's geometric because we're multiplying times 3. How many rabbits will the petting zoo have in year 2 and year 3? Well, if they had 4 in year 1 and we multiply times 3 every year, we're going to have 12 in year 2 times 3 again, 36 in year 3. Explicit and recursive formula. So this one, I'll go ahead and move this up. Explicit and recursive formula. In this case, we need your first term still. So our first term is 4 rabbits. And then we don't have a common difference because it's geometric. Instead, we have a common ratio, and our common ratio is times 3. Now, don't forget, this is the one where you ended up having some fractions and stuff like that. Don't freak out about the fractions. Just try to work through them. Your explicit formula for a geometric sequence is going to be equal to a sub n equals your first term, so a sub 1, times your ratio raised to the n minus 1 power. All right, your recursive formula, you would have to still type out your a sub 1, or your first term, and then you would have a sub n equals, make sure I'm not telling you wrong, your previous term times your ratio. So we know these things. And in this one, what's really nice, we don't have to distribute. We don't have to do any of that mess. All we have to do, erase our first term, put a 4. Erase our ratio, put a 3. Same thing over here. Erase our ratio, put a 3. We know our first term, it's a 4. And then we're finished. It says that the petting zoo can only hold 100 rabbits. How many years can they be in business until they have too many rabbits? A bunch of different things we can do here. I think some people just go ahead and start putting in random numbers into their calculator until they get up to 100. Something that I'm going to do, turn this on. I'm going to plug it in as a function, and I'm going to look at it. So we have this explicit formula, 4 times 3 caret top. And instead of n, I'm just going to use the x. Now, I know this is a little bit different than when we had logistic functions. Technically, you can kind of create a logistic function in this situation, but it's a little bit different. But with logistic functions, we had to do that where we changed the mode and all that. You don't have to do that with this. So we want to look at the table. And the reason why we're searching the table is we're trying to figure out where it's 100. Right? So 100 rabbits happens pretty quick. Right? Rabbits multiply pretty fast. So they're only going to be able to be in business for 3 years. So somewhere in between 3 to 4 years, they're going to end up having more than 100 rabbits. Now, if you were to change that to 1,000, that might be a little more, make you do a little bit more work, but not really. I mean, then you're in between 6 and 7 years. So in this case, once again, don't freak out. If they ask you a question like this and you completely forget how to do this stuff, there's nothing stopping you from going ahead and repeating the pattern. You already found this and this. You could do 4, 12, 36. 36 times 3 is going to be 108. 108 times 3 is going to be 324. 324 times 3 is going to be 900. 972. And keep going, right? So, I mean, you could answer those questions just by continuing a pattern, so don't freak out. Okay, these are pretty straight up. They're not word problems or anything like that, so we're going to go quick through these. If it's arithmetic, you have to be adding the same amount. So this one, we add 30, add 30, add 30, add 30. If it's geometric, you're multiplying by the same amount. Anytime you see that oscillation, positive to negative, more than likely it's going to be geometric. In this case, it is, because we're times -6 every single time. Remember, we talked about being able to find that ratio or that difference by going second term to first term. So if I did this minus this, I get plus 30. This minus this, 30. This minus this, 30. This minus this, 30. Same thing over here. We would just do the opposite division. This divided by this gives me -6. Divided by that gives -6, and so forth. So that's one way that you can find those ratios or those differences if you're struggling with them. All right, the next question says, write the explicit formula for each sequence. So in this case, the first thing you have to do is figure out, is it arithmetic or geometric? If I look at it, it's going up really fast. See how those numbers get big, or actually in this case kind of really small when you think about negatives? So my brain should say, hey, probably geometric. So then I'm going to do this divided by that. So -15 divided by -3 gives me a +5. So then I know that my ratio is +5. I know my first term is -3. We're looking for an explicit formula, just like we did on the other one. My explicit formula is going to be equal to my first term, -3, times my ratio raised to the n minus 1 power for geometric. This one, see how my numbers, you can see like we're ending in 2 every time. That should be kind of a hint. We're going up by 10. So we could have done 42 take away 32, and it gives me 10. Every time I do that, it should give me the same thing, 10. So that tells me my difference. And then we know our first term already is 32. If we know the difference in first term, the explicit formula, a sub n equals 32, plus our difference of 10 times n minus 1. I'm okay with you leaving it like that. If they distributed, you'd end up with 32 plus 10n minus 10. You combine your like terms, and you get 10n plus 22. So you might see it like this, or you might see it like that without it being simplified. All right, next one. Now we're writing recursive formula. So the same type of thing. First, you got to determine geometric or arithmetic. See how those numbers are going up real big? So I'm going to start by doing the 18 divided by 3. That's 6. Now, it's a good idea to check these. I know it is geometric, so I'm going to stick with it. But if you were to get one, the first thing you would need to do is check and make sure it's geometric. But in this case, my ratio is 6. My first term is 3. And then a recursive formula we write with our first term. Have to give them a starting point. And then recursive always has the previous term, or a sub n minus 1, the previous term in it, times your ratio. Let me change colors in case that's hard for you to read. The next one, see how I'm going up by small amounts? So probably a good idea. Go ahead and check it out. 32 take away 28 gives me 4. Oh yeah, I'm going up by 4 every time. So there's my difference. My first term is 28. And since we're looking for recursive, we have to label our first term 28. Put a little colon. And then we go ahead and write the rest of our recursive formula. So the term we're looking for is equal to our previous term plus our difference. And we're done with that. First 4 terms in every sequence. Plug in 1, plug in 2, plug in 3, plug in 4. If I plug in 1, that's going to give me 0. If I do that, it's going to give me 1. So that'll be 4. And look what we're doing. We're multiplying times -5. So it's -20, 100, -500. So that's a little way to kind of get away with it. You know your first term. If you know these things, well, what we just did with explicit, your first term is 4. Your ratio is -5. You can go ahead and start it. 4 times -5 times -5 times -5. If I look at this one I can plug in a 1. If I plug in a 1, 3 times 1 is 3, plus 19 is 22. And then I know that every single time I'm going to be adding 3. So there's 25, 28, 31. Or I could just plug in a 2. Plug in a 3, and plug in a 4. All right, if I look at the next one, it's recursive formula, so it makes it even easier on me. I know my first term, and it's telling me add 2.4 every single time. So all I'm going to do is start with -17.8, and I'm going to add 2.4 every single time. So -17.8 plus 2.4 is going to give me negative 15.4, plus 2.4, negative 13, plus 2.4, negative 10.6. If I go to the next one, tells me my first term, says multiply by 4 every time. So we got 3, 12, 48. 4 times 48 is going to be what, 160, 192. So there's your first 4 terms. Now, once again, you can just plug in a 1, get your first term, or excuse me, substitute a 1, get your first term, substitute a 2, get your second term, and so forth. And that's fine when you're up here with your explicit. When you're down here, I don't suggest doing that because it's not going to make a lot of sense. If you know your first term, just do the action to get your second term, do it again to get your third, do it again to get your fourth. All right, so you got an explicit formula. They want you to find the recursive formula. First thing you need to do is find your first term. So if I substitute a 1 right there, 5 times 1 is 5, plus the 6 is 11, so my first term is 11. And then my difference is always going to be multiplied right here, so my difference is what I'm going up by each time is 5. If I know that, I can list out my first term for my recursive formula, and then I know my term I'm looking for is equal to the previous term plus my common difference. This one is a little bit easier, right? So we already know our first term is negative 4. Our ratio is 5. So we have to list it out that way. First term is negative 4. And then our formula is going to be our term we're looking for is equal to the previous term times 5. And we're done with that. All right, number 22, given the recursive formula, find the explicit formula. Gives you your first term, and it gives you your difference. So all you're going to have to do is put them in the right spots. Remember, your first term goes in front, plus your difference times n minus 1. You distribute. 32, I'm going to just leave it as minus 2n plus 2. We get 34 minus 2n, or some people might write it as negative 2n plus 34. The explicit formula for this one, you can look right here and you can get your ratio. You look right here and you got your first term. So you want to do your explicit formula. You're going to have your first term, negative 2, times negative 4 to the n minus 1. And we're finished with that one. So let's go ahead. This is the finish of the last question. Good luck, y'all. I hope you read this or watched these videos. I hope you guys try your best, and I hope you're successful.